Hi from New York, it's Ask an Engineers.
Hey everybody, and welcome to another fabulous and fantastic Ask an Engineers. We have double the engineers today. Not only me, Ladyada the engineer, but also Amanda the Wozniak, no relation, Wozniak, another engineer. We also have Phil over there.
Hello.
He's on camera control.
I'll be the voice.
And the voice of reason. We've got an exciting show and 2 beers.
Yeah, you gotta do the thing.
Oh, let's open these beers using your rat. Thank you. And then we can continue.
Yes. Cheers.
Cheers.
All right.
Tell them what's on tonight's fabulous show.
On tonight's show, the code is PNP, Pick and Place. PNP is the code. We'll tell you why.
Also,
10%
type
off.
of transistor.
Yeah.
Yes.
10% off everything in the Adafruit store. We will talk about the show and tell, an awesome night of robotics, LEDs, and silent dreams come true. Next up, mailbag. Talk about things that people sent us in the mail. We have some Time Travel Tuesday, some news in the wonderful world of open source hardware, a little bit of Makey Monday, new stuff from the Adafruit Learning System, Wearable Wednesdays, 3D Thursdays, Pi Day, which we do every Friday, new announcement for the Raspberry Pi Web IDE from Adafruit, and our tour of, well, some of it, of the Apex Expo. We'll have some new products, some top secret. We'll answer your questions, and we'll talk about MOSFET at the end because he's not here. All that and more.
He's resting comfortably.
Asking
He definitely has not been grafted into a robot and is roaming the streets of New York.
Not yet.
Looking for pizza.
Looking for pizza and catnip. That is completely not true, and no matter what you've heard, that's a lie. We would never have designed a robot for MOSFET to do that.
Not yet. All right.
Why
so,
would you do that?
So first up, for all that, because we have a lot of new folks since you've been here, Woz.
Yeah.
Introduce yourself, Woz. What do you do, and what do you like to make?
All right, my name is Boz. I am a staff engineer at the Wyss Institute right now. I'm an electrical engineer, and I like to make all sorts of stuff. So I've had projects that involve, in my current job, medical devices. There's a lot of awesome multidisciplinary research in
Do you make electronics that you implant into other humans?
Not implantable electronics. It's actually really, really hard to do that safely. So
But
far,
they
it's
go
all
around
external.
people.
Yeah. We work on orthotics. We work on things for physical therapy rehab. We work on things for clinical interventions in the ICU. So,
What if I donated like $5 million to the Wyss Institute and said I want you to make like a walking robot for my cat? Could you do that?
we could try to scale down the walking robot for kids
Okay.
to cat form factor.
And do you have one for kids or kids
cat.
that?
It might
Cat
be.
form factor.
It might be in the works. It's actually. It's interesting when you're trying to make something for small people, like normally with the medical device robotics, there's actually usually a weight restriction. So the motorized ankle prosthetic requires that you be at least, I think, 170 pounds. Because when the orthosis is a certain percentage of your body weight, if it's more than that, it throws off your biomechanics.
So that's what
so
you do.
You mmust be at least, well, that's like projects I admire for sure.
Yeah.
I don't work at
You don't
that
work on that
company.
one?
No, because that's an independent company. It's iWalk, but their stuff is wicked cool. And
So what are some of the fine projects that has come out of the Wyss Institute and your research group?
we've got one that's on the website, which is a vibrating mattress for treating infants in the neonatal intensive care unit who tend to have apnea or they stop breathing.
So it's like a little jiggler.
Yeah, it's a very therapeutic way of shaking the baby, and there's a video up on the Wyss website that talks about the technology, and so that's one of the projects I've been working on.
So they have like stuff in their lungs and you have to shake it loose?
No, it's that if you're born too early, your respiratory system is the last part of you to develop. So because you don't need your lungs until you're born. So if you're a premature infant, your respiratory control system, like all of the things that compensate, like how much blood gas you need, that whole control system is immature and unstable. And so this is a clinical therapy intended to address that. So there's a really cool video up on the Wyss website somewhere in the library.
And Woz, if people wanted to see like some of your other work, like documentation and process and open source hardware, you did a great presentation. What was that about? That was in September.
Yeah, I gave a presentation at the Open Hardware Summit about design for manufacturability and ethnography of use. So sort of thinking about who are your customers, what are you designing, why are you designing it, how do you want to get it made. And actually one of the things I need to do is put all of that stuff up somewhere because I don't even have a website.
You should get a GitHub account. You should put it up there.
Yeah, exactly. I need to just start posting things on GitHub.
You don't even have to do like a website. You can be like,
but for
it's up there, whatever.
That's true. And for previous projects, for the Ninja badges, all of that's hosted on the ninjas.org website. We put all of the files, all the source code, videos of how we ended up hand assembling 500 or I think at that point 700 badges.
Yeah.
It's all up there. So, right, it's sort of like everything's project based, but yeah.
Okay.
All right, excellent. Okay, we're going to keep moving, and we have a lot of stuff to go over. So, code is PNP. Don't forget.
3 letters. I don't think capital letters count. I think you can just...
It could be all caps,
is it case
all lowercase.
sensitive?
Nope, it's not.
No, I don't think so.
Nope, it's not. Well, okay, show and tell. Let's talk about what's on show and tell.
All right, first up we had Dino. Dino came back, 3rd time's a charm, with his robot. His robot now rotates.
Yeah.
It has 3 cameras and disappeared into the night.
It has night vision also.
James is getting married at some mines. What are these mines?
He's getting married in the Woliczka mines, which are a UNESCO heritage site in Krakow.
Okay, there's something great about these holes in the ground. Anyways, he's gonna get married in this hole in the ground. And I don't know, I've never been to the mine. So he made his own custom photo booth using an old laptop, which is actually kind of neat.
Yeah, it was really nice.
Ken had his first Scratch program. He's just learning Arduino, and he's pressing
he was
buttons.
using that MIT Creative Learning site.
Yeah, so that's kind of cool. We had Lon.
Yeah, the LED sound meter.
Yeah, he showed up with his kind of sound meter, view meter thing. Actually, this was for some event, and then I think it just kind of got out of control.
Yeah.
Kept working on it.
It's a great project.
Michael showed up with, his motorcycle. He's just got an Arduino like 2 days ago, and he's like, buttons and LED strip, and stuff's happening, and he's excited. And it's his first project, so it's really great. Ethan showed up with his Tesla coil. It is bigger than he is.
Yes.
I guess that's a rule. You can't make a Tesla coil smaller than you, so I guess it has to be bigger than him. So go Ethan, try to get it executed. Maybe he'll come back next week and fire it while on the show and tell. And then finally we had Silent Tom with his silent crystal set. He has some sort of galenic crystal crucible thing that he's using to, and an awesome capacitor.
Yeah,
thing.
Really huge, really nice air dielectric tunable
So it's like some sort of like a crystal radio he's making that, and unfortunately audio wasn't working, but looked kind of cool.
Okay, everybody who is on the show and tell gets that as seen on the show and tell sticker. They just have to email support@adafruit.com and they get a spiffy
You can get as many stickers as you want.
Yeah, we have someone who's collected like 5 or 6. It's pretty cool. Ladyada, how do they get on the show and tell?
It's very easy. Just go to plus.google.com/Adafruit and go to the post where it says, hey, post here before the show and tell. Get added to the list. We'll add you to that circle. And so that way, anytime in the future when we have a show and tell, you'll get an invite at 9:30. You'll be able to show up, show off your project. Get yourself invited now, and that way you can show off a project next week.
And no pressure, Waz, but you can always come and visit on the show and tell.
It's true.
And show us your project.
Unless you're partying.
Which is possible.
Yeah.
But you can also do both.
In a robot.
We had parties sign in. We had that party from the hackerspace. There was like 20 people there now.
Okay, moving right along because we're going to try to get to a lot of questions tonight. First up, mailbag. Every week people send us things in the mailbag. This one, I'm new to electronics world and I just discovered Adafruit in December when I found the floor. Every time I went back to your website, I found more and more stuff and more information. And finally, ask an engineer, and I keep telling my friends and family how great the website is. Lady, I'm old enough to meet your mother, so I hope it's okay for me to tell you how proud you are and all you've done. So
Thanks,
inspired,
Mom.
by your intelligence and vision and drive. And I was so thrilled when you were on with President Obama this week. What you're doing is absolutely wonderful, and yes, you're an inspiration to girls of all ages. So I just want to send you a note, say thank you and congratulations. I wish you success, and you have a good heart, and you're making the world a better place. Your friend Kim, who could also be your mother.
Ow, my teeth hurt.
Isn't that nice?
That's so sweet.
Yeah. And
did you send like a brownie with that or something? Like, expect cookies.
No, and what's interesting, because even though that you were on with the president, and not everybody, I don't know if you knew this, not everybody likes the president. It turns out.
I don't actually agree with the president.
Yeah.
I don't think some things he's doing is right.
Yeah, and so, but
I let him know.
But because but people said they knew that. They said it was really cool that you were able to go and bring up some very important questions, some suggestions, and we're not political at Adafruit, but I think it's good for everybody to get involved and try to make politics work for them and government work for them.
Thank you, Elbow.
Yeah, this is what Elbow says. Yeah, so good job, lady.
All right, thanks. Whew.
All right.
No pressure.
No pressure.
Yeah.
Okay.
Next up, we're gonna have a very short time travel Tuesday. You know what happened? Back in
It looks like a camera.
1947, the first Polaroid.
Oh,
Nice.
Yeah. So did you guys ever use Polaroids?
Yeah.
yeah, totally. We've taken Polaroid, a bunch of Polaroids together.
Yeah, I actually have a Polaroid back for a 120mm format camera. My dad always uses them to take like test shots before,
Actually, some
using
guy,
film.
some sales guy at Apex said he had a Polaroid. He was gonna take a photo if he wanted to, and I was like, that's really weird. I said I felt bad. I'm like, 'cause I don't want you to waste your film
Yeah.
because they don't make Polaroid film anymore, right?
I thought they licensed the IP and someone was manufacturing film to the Polaroid process. It's not quite as bad as like Kodak discontinuing their processing chemistry, so I think you can actually still get Polaroid film.
Okay, that's good.
All right.
It's just not made by Polaroid.
Next up, some big news in the world of open source hardware. I don't know if it's big, but it's news.
Yeah, what happened?
Well,
heard about
Embed,
this.
the Embed
Oh, yeah,
yes.
SDK goes open source.
That's right. The libraries, you could use the GCC compiler. There's an ARM compiler for this core, the LPC 1768, I think. And but the core libraries, which is kind of the magic of what makes the Embed easy to use, were finally open sourced. So that is really awesome.
What is the Embed for the people who've never heard of it? Because we stock it.
Yeah, we
have
do.
it.
It's a ARM.
It's 10% off.
Yeah, it's 10% off. It's an ARM Cortex dev board, and it's just a very powerful board, and it's an interesting online compiler. So you can go online to write code, and you can sort of share it with people, which is interesting. But I kind of always wish that there would have been a way to get your code offline too and compile it offline, because the compiler they use is $5,000, and it's ARM, so they got special permission to use this compiler online. But like you and I are not going to go and buy a $5,000 compiler,
No, yeah.
or a couple $1,000 compiler. So luckily, they've now ported it all to, I believe, GCC, and so you can use this very powerful chip, the LPC 1768, using their bootloader and system, and it's great. Actually, I like the boards. It's very powerful. It's very cute. It can do a lot.
Is that the same core as the LPC Espresso?
The LPC Espresso does have a 1768 as well,
Okay.
but this one is, I think, it's a little more compact. It has a little bit more going on.
Yeah.
Okay. And I forgot the fellow's name, it slipped my name, but he was a very vocal voice in the Embed community, and I think it was Emilio, maybe?
Emilio.
And then he joined the team, and he's been doing a lot of the open source efforts.
Yeah.
Very cool. Okay. Next up, you're going to have to help me out with this one, Ladyada. This is a shot from one of our Manufacturing Monday posts. What is this?
This is a lot of our Ultimate GPS modules being manufactured. So we make them in plates, and each panel, you can see there's multiple, there's like 9, 12 panels here. Each panel contains 25 GPS modules. So we pick and place them right now, 25 at a time, and then we actually hand place the GPS module afterwards. And so this is the boards after they've been pick and placed, and after the GPS module has been placed by hand, waiting to go into the oven. To save power, we just turn on the oven for half an hour to run all the boards for the day through it all at once instead of keeping the oven on.
Yeah.
Yeah, the reflow oven was our kind of latest addition to the Adafruit line. We'll talk about maybe some new ones coming up soon. But
so what's nice is that because it's not a batch oven, it's a conveyor oven. We can actually you just put the boards all in a row, and they just run.
And you can make them through.
Yeah, all at the same time.
Okay. Next up, we have every Monday we do Makey Monday, and Makey Monday celebrates all the cool things. Makey is a little electronic kit that lets you plug things into the physical world, so anything becomes a keyboard. This one we're not going to play the video, but this person Jay Views did make an entire musical instrument, an orchestra, out of the produce section.
Yeah.
Basically of a grocery store.
He played Massive Attack Teardrop on Beats, which is just kind of neat.
Yeah. So if you're looking for an inspirational project, check this one out.
Yeah.
And the Makey is of course 10% off.
Yeah.
It's fine. We have this. All right. Next up, Ladyada, you have to go through these.
Yes.
Adafruit Learning System. Some big updates this week.
Yeah, we've been moving tutorials over.
Yeah, lots of tutorials.
Okay.
Actually, Waz, have you checked out the Adafruit Learning System?
I have. It's fantastic. We actually have students in our lab that are using, I walk by and I see, a mechanical engineer using the learning system to learn Arduino. It's fantastic.
That's cool.
Because all of our students want to be able to build more embedded projects.
Yeah.
And everyone wants to be, able to not just be engineering, a joint, but then they also want the motor drive for that joint. So I have tons of people at work that I walk by and they're using the learning system for everything. And I use it every time I need to check things about like the LCDs, or outside of work, I'm actually using some of the LED panels to help out my guitar teacher with the lighting display for his business. So, it's really awesome. I love it.
Are the students finding it on their own through Google, or?
They are. That's the best part.
Yeah, that's what we're seeing
Yay,
too.
Google.
The organic traffic that's coming in is huge. So we already hit a couple million page views, and
Yeah.
and we don't like advertise at all. So it's just people just stumbling
Yeah.
upon it.
Yeah.
And I really like it. I'm glad that we are moving all of our tutorials over to it. It's a tedious process, so while it's happening, you might find that you might have to click a couple times because the tutorial's moved like once or twice, but eventually we will clear out all the links to Ladyada.net and have all the products go to the learning system. It's just, there's a lot of tutorials. There's like 250 tutorials that we have tutorial pages.
Yeah.
Because some tutorials are like really big and some tutorials are short. So we're going to get there, and
Yeah.
be patient. Also, you can subscribe to the RSS feed to get notified of new and updated tutorials. Which is great.
Okay. Speaking of, which ones did you add this week?
This week, Tyler and Matt have added, and Jeff added our laser tutorials. This is like 6 or 7 little guides to taking care of, purchasing, equipping, maintaining a laser cutter. I don't know if you've used it to maintain your laser cutter.
We have a separate maintenance program for the laser cutter that
That's
we
great.
already have.
Well, a lot of hackerspaces don't have a maintenance program, so check out what we talk about, because we do mention how to maintain it, what filter to get, what kind of materials you can cut.
It's
It's
really important because a lot of people, when they get their first piece of equipment, they don't necessarily know what the maintenance schedule is. Like,
Yeah.
how do you clean your mirrors?
Also, like, what kind of fire extinguisher to get.
Yeah.
You shouldn't use the generic fire extinguisher. To
Yeah.
find out what kind of fire extinguisher you get, read the tutorial.
Yeah.
We also updated the
Oh, this is a new one.
all about Arduino Libraries. Yes, this is a new tutorial, so I can't read it. This is a tutorial by Bill Earl. Thanks, Bill. He did an excellent job. He helps out a lot in the forums doing support for our customers. And number one support request is, or support difficulties we've seen is, it's very complicated to install Arduino libraries, especially for people who are not very computer savvy. It's also just very confusing because it's different on Linux, Mac, and Windows.
Yes.
So, and the library, and the folders are named differently. So it's a little crazy.
And sometimes they're hidden.
So he did a really in-depth guide to how to install libraries, how to uninstall libraries, what kind of errors you might get and what they mean. This is really handy. I don't know how processing managed to solve this, but and also I think Arduino will get better at this with 1.5. They'll be adding some more library handling functionality, but until then, check out this extremely awesome, extremely detailed tutorial by Bill. It is great.
Okay, next up, one more.
We have a new Raspberry Pi tutorial. I think this is kind of nearing the end of our Raspberry Pi tutorial. Not that we would not do more tutorials, but the end of this Learn Raspberry Pi with Simon Monk. This is a tutorial on controlling something that's like mains powered using a power switch tail, which is a safer way to control mains powered stuff using a PIR sensor. So this is actually kind of a boring example. It's like when somebody shows up, just turn something on or off.
Yeah.
It's kind of like it's like you can just buy something off the shelf, but it's easy to extend this.
Yeah, I have a less boring example that we've actually used the power switch tail for in the lab, which is a lot of when you're doing genetics, you have things like gel electrophoresis that you want to run, which you run at a couple hundred volts. A lot of people do things with magnetic beads, and we had, I think this was about a year ago, had a student who, actually not just a student, he was like a PhD researcher who wanted to build a pulse magnetizer. So he was trying to build something that would generate in a small area a 2 or 3 Tesla field. And he needed to be able to charge capacitors up to a couple hundred volts. And he wanted to charge them basically up to 120. He wanted to diode rectify mains. And I'm like, all right, the way we do this, and we do it safely, is you use the power switch tail, you control that, and then if there's a problem with mains, the power switch tail is what fails, and everything else is great. So it's wonderful to have pieces of fail-safe equipment like that.
Yeah, it's great because it's opto-coupled. So it's nice is that this is a tutorial showing, like we had a tutorial using the PIR sensor, now this is taking it a step further and saying, okay, how to integrate with that, with controlling main stuff. A lot of people just use like a relay board. I don't suggest it when you're dealing with mains. There's a 200 volt, a 220, 240 volt power switch tail. We don't carry it.
But you could get it if you wanted to.
But you can get it from the power switch tail shop or other UK distributors or European distributors. But this is a much, much safer way than wiring up a relay. I don't suggest it.
No, relays can be dangerous. Relays can bounce. And
well, the problem is you have to switch on the hot, which means that you're switching the most dangerous part.
Yeah.
You're switching the only dangerous wire, because if you switch any other wire, your configuration isn't safe. So power switch tail is the way to go. I like them a lot. Anyways.
Yeah, Ustream must have featured us or something. Someone said there was 81,000 visitors
To what?
to the show tonight.
Well, Awesome.
Yeah, when you say that, there's a bigger echo. Anyways,
Cool.
so maybe we'd be featured on the homepage.
Okay, great.
Yeah.
All right.
Good stuff.
Anyways, this is a good tutorial. Check it out. SimonMonkey does a fantastic job with these tutorials. They're very straight to the point and detailed, but address what people want.
Yeah. Okay, next up, Wearable Wednesday.
Wearable Wednesday.
Every Wednesday.
Flora projects. Not only Flora projects, but other projects. Although
Yeah.
recently we've been trying to get all the Flora projects.
Yeah, so we have 3 things. Becky Stern puts these together. I just
I don't know
picked
what's
a few
going
I
on
like.
here, but this is
I
cool.
like this one. This was like, this is the next frontier in hoodie,
I don't know what
hoodie
the hell
technology.
it is, but it's cool.
Yeah, this is what all the kids are going to be wearing soon. So, you know how Google Glass came out? Well, this is Mark Zuckerberg's version. No, I don't know.
It's a hoodie on a hoodie.
Yeah, no, I really like this. And then there's some really beautiful
EL shoes, those are nice.
Oh,
EL
wow.
shoes.
I think if you're going to do EL, I like this sort of like inside something, so it's like side glow.
Yeah,
That can be
very
good.
diffused,
nice.
very pretty.
So I really like these. We're going to be doing an EL
nice
shoe
shoes.
project soon.
Yeah,
And then Becky has a quick video we're going to
Yep.
watch real quick. And this is, maybe you could set this up a little more. What is this?
Oh, this is, so we have 2 sensors for the Flora. It's actually 3 if you count the GPS. Sensors for the Flora so far. We have the GPS module, which can do location, speed, stuff like that. Because the GPS. We also have the accelerometer magnetometer module, which is a 6-degree freedom sensor, so you can do 3-axis accelerometer and 3-axis magnetometer, so you can do like
Oh, nice.
which way you're going, which way's north.
Yeah.
And she showed a project about that last week. And this week she's introducing the Lux module. This is a really high-end light sensor that, what's nice about this light sensor is it has 2 sensors inside of it, one for infrared and one for all vision. Because there's no such thing as just visible, human visible light sensor.
Yeah.
You can get one that covers all, including IR, and one that just IR, and they can subtract them to get human visible light. So that's actually really handy because otherwise most light sensors pick up IR, and so
It's true.
they're not that useful. So it's a great I2C sensor. Easy to sew on, low cost. Take it away, Becky.
Today on Wearable Wednesday, we're getting started with the Flora luminosity sensor. It's the latest in our line of popular sensor breakouts that we've brought over to the Flora PCB design, which is round with easy to sew through pads. And I've just got it hooked up to the computer where I've downloaded the library for this sensor, and I have the sample sketch running, and it's spitting out light values to the serial port. And what's really cool about these I2C sensors is that they have 2 sets of data lines, so you can easily daisy chain them together with conductive thread. And this light sensor will actually break out the infrared and visible sections of the spectrum, so you can make your project react to light you do see, light you don't see, or a combination thereof. So if you make a project, we would love to see it on our weekly show and tell on Google+, and don't forget to subscribe to our channel here on YouTube.
Okay, on the 3D Thursday, every week, 3D Thursday, lots of stuff. I just picked up a couple of them. I like this one. This is a little 3D printed case for a Minty Boost that fits into the back of a flashlight. It's kind of nice. Chris Kortwright robot arm. He's making a Raspberry Pi snow blowing.
I like the raspberry colored plastic.
Yeah. And then New York Times had an interesting article. Will the 3D printer be the home appliance of the future? So I'm going to flip this over to you, Waz. Do you use a 3D printer?
Yeah, we use 3D printers all the time.
Yeah.
Which kind do you use?
We have a couple. So because the different 3D printing technologies have different trade-offs. So we have, I forget the name because we actually just upgraded. Because we used to have a Dimension, but we ended up changing, and it's the same. It's an extruded plastic 3D printer, so it's the same style as a MakerBot, where it's got.
But it's like one of the like a Dimension style.
It's a Dimension style, so it's got a cabinet and it's got an ABS. It's got a head that extrudes and deposits ABS plastic and support material, and then we also have an Objet, which deposits like very tiny dots of material that then UV cures. And the nice thing is they have different trade-offs because. Something with extrusion has very, extrusion-related mechanical properties.
Yeah.
The Objet, which is much more expensive and much more finicky, produces really, really beautiful stuff. Like it produces mold quality prints.
Yeah.
So you don't even have to.
They don't have like a shear.
They don't have a shear face like the. Yeah. It's basically this just beautifully clean finished material that you can sand, you can polish, you can drill, and it doesn't fracture at all because there's no extrusion lines. It's literally like. If you thought of a 1200 DPI printer that worked in 3 dimensions, that's what the Objet is like. So, and it also prints biocompatible plastic.
That's cool.
Which is pretty rad.
Do you ever get a 3D printer for your home?
I might.
Yeah.
But I have to be in the habit of fixing more things. So I'm still like doing everything at a pretty, do I have a screw big enough and a 2x4 scale?
Yeah.
And 3D printers are great when you need to make something very particular or when you need a certain amount of precision. But I'm really excited about 3D printers for casting, for making different appliances.
Yeah.
Silicone molds. I think it's just so useful to be able to just 3D print a mold rather than having to like make a primary, then make a secondary cast. You can just do so much with 3D printing, and we see all of the different researchers and student groups, or students and all the staff relying, the 3D printer is in use all the time.
That's great.
Nonstop. So
And do you, because you're in the biz, do you see an intersection of bio and 3D printing?
yeah, there already is. We use
Let's hit you up for that one.
Yeah, I know. But so things you use 3D printing for, like beyond making cool pieces of art. If you need to make a custom appliance, a lot of biologists want to be able to run highly parallel stuff in the lab. They don't want to have to like do one thing, so they want to be able to set up 40 vials and have like them all running the same protocol, or they want to adopt a piece of benchtop equipment. And fastest thing to do is, do you know the attachment you need? Okay, that's a little funky. Let's just 3D print it.
Yeah.
If it doesn't need to be sort of production industrial grade, you don't need to spend the time to have it machined or made out of aluminum. Oftentimes just the plastic adapter is what you need.
Yeah.
all the time. And people want to do things like 3D print. You actually saw this at the Open Harbor Summit, using 3D printing to try to make matrices for cells to grow on, 3D printing to try to reproduce vasculature that you then sort of like 3D print in a PDMS or silicone type material, where they were 3D printing, I think, in molten sugar. You wash the sugar away, you have these channels, you can then try to actually grow blood vessels in the channels. People are doing a lot of really cool stuff with that.
So the cells have some place to grow.
Cells have some place to grow.
Because cells need structure.
Cells
They
need
can't
structure.
just grow up, yeah.
And so the 3D printing is useful both at the scale of like the MakerBot for making utilitarian parts to use in the lab, and there's also a lot of interest in adapting MakerBots to print finer structures that you can use as cell matrix, because cells care about what they grow on,
And you can
that's
turn the matrix. You can make the matrix into like sugar or something.
Yeah,
The
you can make it
cells
sugar, you can make it
digest
collagen. Yeah, things that are biocompatible, things that the cells like to interact with.
Okay.
It's really cool stuff. People are even talking about 3D printing replacement organs, but you have to, get some.
Well, you
control
can get
at
like
some point.
tissue, like
The idea is to recreate tissue.
if you could 3D print skin or tissue or collagen.
Well, it's more
maybe.
like 3D print the structure that the tissue wants, because every tissue has its own mechanical structure. So you can 3D print what's called a scaffold,
Yeah.
and then put the right type of cells on the scaffold. And then, the interaction between the cells and the scaffold material, like if it's a sugar or collagen, and then the growth environment you put it in, if you just put it in a bath, or you put it in a plate, or you put it in a stretching machine, will determine how the cells form tissue.
Yeah.
And that's cutting edge research, and for that, everyone loves different 3D printing technology.
That's great.
So, it's awesome stuff. Keep making tools.
Okay.
No 3D printing Thursday.
Yes.
Yeah. Next up, this is from our Flickr Pool Friday, where basically John was setting up some cameras, and he decided to make this little image. So he has very dramatic photos here at Adafruit. So he says, the last part you're like, I knew him ratio. So I thought that was neat. So check out some of the photos that John's been making. Pi Day. I have a question for you, since you're in a research environment. Has anyone, Arduino obviously hit.
Yes.
Has anyone started looking at the Raspberry Pi for any reason?
Yes.
Yeah?
Yeah. I'm not sure if one of the engineers upstairs, he was using Arduino with an Ethernet shield. I think he might be switching, because he has a sort of web-based application that he wants to run in the lab. So if something's running in the incubator room and he wants to keep an eye on it and actually like control it remotely, because again, biology is 24/7, cells don't wait. I think he
never sleep.
Cells never sleep. They just keep on dividing. You can't like tell them to.
Cells have they don't have a sleep cycle or any kind of rest cycle?
No, circadian rhythm is higher order function. Like cells don't care. They care about temperature, food, gas, how many cells are nearby. Sometimes they don't like it when they get too crowded. And I'm not sure if he's switching over to the Raspberry Pi yet, but he's been talking about it nonstop for the last 6 months.
Okay.
So he might be.
That's a lot of talking for 6 months. We do have them in stock.
He's upstairs. So I only see him every now and again.
Yeah.
So.
Well, if he was using an Arduino with an Ethernet, this does lower the cost, and it's just all on one. So.
And he
can have a
really
web browser.
likes
can do a web
Linux, and he really likes just having native support for stuff. So. Yeah.
Okay. Well, we have a couple projects that we're going to show. So this one is kind of neat. This is a web hit counter.
Yeah.
Using our cable and our Perma Proto for Pi, and when they get hits, this thing lights up. Very
Yeah,
cool.
that's like a little Google, like, I don't know if that's really neon, maybe it's like a mini neon light, and they're using a relay to control it, but I think it actually runs off of 5 volts. It looks like, I think it's a USB powered thing, so it's a safe voltage to switch.
Yeah. And then next up, there was a Raspberry Pi Jam this Friday in New York, and Tyler and Justin tuned in, and they talked about the new Adafruit Learning System Raspberry Pi Web ID. It was in New York, but they had a they tuned in. They did a hangout there.
That was like we were like not here all week, so.
Do you know the latest updates to the?
I do know some of the updates, not all of them, but I can cover most of them.
Yeah, you wanna?
I know that we've been fixing bugs. The features are mostly done, but we're still in alpha, so we're fixing bugs. We're having some tab to space conversion issues because it's Python and
so
Python thing.
4 new settings on the settings page.
So
soft tabs on or off, tab size, show invisibles, manual git commits and pushes.
Yeah, so that's those are the big things. So basically, like right now, kind of automatically pushes everything to Git, which like people don't like necessarily because it's like sometimes they've compiled Python files or files that shouldn't be committed. So like we have a little bit more customization about that. A lot of it is about like tabs and spaces because a mix of tabs and spaces can really screw up your Python program. There's some Git ignores. There's just some bug fixes.
Yeah.
I mean, it's nothing. There's nothing like really crazy. It's mostly like a bug fix list. He's been really going through the issue list and taking care of it. So it's getting more and more stable.
Okay. And then next up, we wanted to post up about this. We have a maker business day that we try to do where we have all the resources for makers kind of going pro. So Make has a Maker Pro newsletter.
Wait, is this for people who like start businesses or like consultants?
For people who start businesses, anyone who's a maker who then decides to make a business and getting into manufacturing, getting into things like Kickstarter and crowdsource funding and taking investment. So it's kind of a neat resource, and I'm glad because we have our little series of articles, but this is a newsletter and Make is interviewing people. Yeah. And speaking of, because this is where we just got back from,
we were gone all week.
We were gone till yesterday. We were in San Diego.
We were gone from Tuesday till Friday. So it's actually 4 days, but it's really 2 days because it's flying one day and flying back another day. But we were at Apex Expo, which is sort of a surface mount and electronics technology expo in San Diego. It moves around. I once went to one in Boston, so I know it at least once in a while shows up on the East Coast. I think it tends to go between San Diego and Las Vegas. There's a lot more manufacturing on the West Coast and the East Coast probably at this point, but hopefully it'll make it all the way to the East Coast eventually again. That would be really nice. So we'll be able to take a lot more people. Phil and I, say hi, Phil.
Hello. Sorry, I'm off to the edge here.
Hello.
Yeah, we went out for a week.
We went out for the week, and that's why there's not as many new projects. But it means that we got to research a lot of the really great tools that we might want to buy. We're actually in the market to purchase a lot more equipment. Yeah. Now that we have all the space,
it's a huge amount of space.
We have to fill it.
Yeah. So we're looking at 3 pick and place machines right now.
We looked at a couple of things. We looked at selective soldering machines. We just got a reflow oven, but we're always looking. What will we do after this one? Yeah. Automatic optical inspection machines. And then what else? I think we have hand tools and stuff, and also just resources. We saw some other really cool stuff which we'll be posting about. But for the most part, the main goal was to look at pick and places, and it's very hard to compare pick and places unless you go to this expo. This is like the place to go if you want to compare multiple machines because you can actually go. Like every manufacturer is there. There's like 20 or so pick and place manufacturers showing off live their machines, and they often have multiple machines.
So they were doing live demos?
They'll do live demos,
Yeah, and we'll answer some questions as this comes in. Someone wants to know, is one big pick and place machine better than several small ones?
Yeah, you probably want to have one just because you only have to program that one machine. It's easier to maintain one machine than multiple small machines. We've had the pick and place we have now, which is like I call it like pocket pick and place. We've had it for like 4 years now. Yeah. And I got it originally because it was one of the only machines that would run on 120 volt power and would run on like less than 10 amps, so it would fit in my apartment. It is an apartment size pick and place. There's not a lot of pick and places with vision that can do that. It can go down to 0.4 millimeters, it doesn't like to. It can do 0.4 millimeter pitch. It can actually do like small leadless parts, large parts. It has some quirks. It's not very fast. It can only place like maybe 1,000, 2,000 components per hour. So it's like a component every second or two, every 2 seconds or so. And it takes much longer for components that have to do with a real vision check, like leaded parts, chips, and stuff. And so it's definitely one of the reasons why we're having difficulty keeping some of our most popular pick-and-place products in stock. We have to upgrade this machine. The machine has been great. We love it very much, but it just isn't fast enough. We need something much, much faster.
So we narrowed it down to 3.
So but before I went, I researched a whole bunch of pick-and-place machines, and there's like 20 manufacturers. Cut out 10 pretty fast because they just didn't have anything that made sense for us. We wanted a flexible pick-and-place, one that could basically do everything. There's some that are specialized, like chip shooters. They're only meant for small components. They're meant to do passives only, really. And then you would have a separate machine to do big chips and stuff. And that makes sense, but that's actually, we decided we wanted to have like a flex mounter, which is a pick and place that can kind of do it all. And luckily that's a fairly good market right now, and there's a lot of machines out there. We also had a size specification, number of feeders we wanted, speed, budget. Yep. So we also wanted to get a new machine because we wanted to have a service contract. We wanted to be able to get components for it. You can get a used quad for a couple $1,000s, but like good luck getting it up and running.
Yeah, there's definitely a lot to be said for having vendor support for what you want.
So the 3 machines that we looked at were the first one is
Juki.
Juki makes really fantastic machines. These are very compact. They're very flexible. They have really good software.
So what do you mean when you say flexible?
When I mean flexible, it's like it can handle all sorts of feeder sizes. It can handle all sorts of chips.
So it can do different tapes. It can do feeder tubes.
It can do trays.
Trays are nice.
It can do tray. Yeah, it has a tray holder. It can do tubes. It can do chips. It's just called the flex mounter.
Yeah.
Because it can do all this stuff. It has like 80 bays. It has bays on the front, and then which is where I am, and on the back there's one too. These are all conveyor style, but you can manual load them just fine. Jukis are really well loved. This is the KE2080. Has about 16,000 components per hour.
16,000.
16,000 components per hour.
Nice.
I mean, that's like optimal.
Yeah.
Like in reality, you're probably gonna get like 10,000 because it's like if you have big chips. This is like if you're only placing capacitors and resistors and like it's set up so the multi-head.
It's just right.
Yeah, and it comes in either 6 heads or 8 heads, I believe, or maybe 4 or 6. I don't remember exactly. So there's multiple nozzles. Not heads, I mean nozzles. So it has 4 nozzles or 6 nozzles. There's one head, but it can pick up 6 components at a time. So as we saw with the GPS modules, usually you have your boards tiled. You don't have one board, you have 20 small boards, and so it'll actually pick in place 6 in parallel. So it'll pick up 6 10K resistors and like place 6 at a time, and then to pick up another 6.
Yeah, because the transit time from the feeder to the board and the work area is like a huge amount of time. And
so it goes over this feeder and then quickly picks like 1, 2, 3, 4, 5, 6 components up on the little nozzles, goes over and then places them at a row. So depending on your layout and how you design it, it does optimize it. So the Juki KE2080.
Also the Juki, you can do a magazine load, and they have smart feeders.
They do. They have smart feeders. Although like I don't care too much about smart feeders. They have a barcode technology that you can add on later. These are all
actually like barcode all your readers.
Yeah, you barcode the feeders, and then the feeders are barcoded, or I don't remember if this was barcoded. They had RFID because we saw so many different machines, but I believe they're barcoded and the reels are barcoded. So when you start the machine up, it says you have to scan what's in feeder number 1, what's in feeder number 2, and you have to go through, and then it says like if you screwed up, or also it'll change your program depending.
Oh, so it's trying to remove all the different like potential sources of error if you like load it differently just on Tuesday than you did on Monday.
Right. So the really good pick and place is like you can load any feeder with anything you want, and you'll barcode scan it, and it'll be like, oh, now I know where to find this component.
Yeah.
Also, you can have multiple feeders with the same component in it. Like, for example, your 10K resistors. Let's say you're going to just go through so many. You might have 5 feeders with 10K resistors all loaded. And then you just tell it, hey, these, you barcode scan them, and then it'll know automatically that when one feeder runs dry, it goes to the next one. So these are high-speed machines.
Really nice machines.
Okay.
These are
Next question that someone had. When does it make sense to have a pick-and-place machine? What quantity of boards?
I mean, some people go to contract manufacturer. We have a lot of different designs, and we try to have fast turnaround and fast design time. For us, it makes sense to do it in-house because we don't want to have to do the wait of having a couple weeks to get stuff to the contract manufacturer. It's also, it is difficult to get a kit together for a CM. You'll kind of know You'll know if it's time.
Yeah, if you're doing a lot of surface mount stuff.
Yeah, I mean, it's not for prototyping. I mean, we manufacture thousands of boards a week, easily. I don't even know how many, but and I'd like to do tens of thousands, but right now we can't. So this machine would let us do that.
So that was the Juki.
Juki
So that Juki's in the running. Next up.
KE 2080.
My Data.
We also looked at the My Data. This is the MX100 SLE. Can you read what it says? The My...
Yeah, 100 SXE.
SXE, which is the single head. There's also the DXE, which is the double head. It's at the single head, 10
nozzles.
No, it's 10 feet long. Yeah, it's 10. The 10 is for 10 feet. There's also the 14, which is 14 feet. Assuming. Wow. And this is actually interesting. It's the My Datas are kind of a totally different design than other pick and places. I mean, they still have the Hydra nozzles. They have 6 or 8 nozzles. I don't remember. Also, approximately 16,000 components per hour. Although, from what I've heard, that's really way more than reality. They're actually much slower than that. So
again, it's optimized and optimized.
No, but even that, it's the My Datas are even more optimized than optimized. So it's actually probably really 13,000, and actually it's more 10 probably in the end. What's interesting about them is, unlike the Jukis and the Samsungs, which we'll talk about next, they don't have feeders on both sides. So most are there's a conveyor that goes down the center, and then there's feeders on both sides. These are actually meant to kind of go up against a wall or something. They're not meant to have feeders on both sides. The feeders all load in the front.
Okay.
And the feeders load into magazines, and the feeders are actually kind of really small, elegant things where you don't have to pull back the tape and wind it. I've loaded the feeders on this pick and place hundreds of times, hundreds of times, and so it is annoying. It is annoying to load feeders. These don't have that issue because you just push the tape in, and there's a little knife that cuts the cover tape off, and it pulls away. It's kind of beautiful and elegant.
So the idea would be that you would have you could put cut tape in it, or you would have a lot less part loss.
You have cut tape because it doesn't have to have it doesn't use a pickup reel for the tape, so you can use cut tape and short tape, which is we don't, but I can see why if you're a contract manufacturer and your clients are jerks and they send you cut tape. If you have stuff sent out to contract manufacturer, don't send them cut tape.
Buy Digireel.
Seriously, just get them a reel and give them 20% extra parts. That's
floor
crazy.
loss.
That's crazy pants. But some people do. They're I want 100 boards and I'm sending you 100 regulators, and I'm like, wow.
And that's hard.
That's why I'm not a contract manufacturer, by the way. So that's one of the things that's nice about it. It also does have the sort of smart feeder system. The things about the My Data that are cool, you can get an add-on that does testing on the fly, which I think is really neat. So as it picks up a component, the first few components out of a reel or cut tape that it picks up, it'll actually use a little smart tweezer and it'll test the components. It'll test resistance, capacitance, forward voltage, and leakage.
Reverse leakage current?
Yeah, reverse leakage current. So you can actually test passives and small transistors and stuff. Which is kind of totally awesome, but I didn't even ask to be quoted for that because I don't even want to know how much it costs because I know it's a lot. The thing about it is that it's a bigger machine, it's actually physically bigger, so that's something we might have to consider. We don't have that much space. It's fairly expensive. The My Datas are not as cheap as other machines. The feeders are cheaper, but you have to get all this stuff. So even though the feeders are less expensive than other feeders because they're so simple, it
takes more stuff to go with them.
You have to get all these magazines, and the tray holder is much more expensive.
How would you do the knife blade? You'd have to do maintenance. So for every mechanical feature you have to do maintenance on that potentially.
Yeah, but the knife blade is I think it's removable. It's very simple. It's a little blade that nicks it up. And also the software is Linux based. And I use Linux, I love Linux, but I wouldn't be proud of saying that the software for my $250,000 machine is Linux based, and you have to use a text editor. So it's kind of like VI.
Yeah, the Juki.
This board placed with VI.
Yeah, the Juki and the Samsung both have visual interfaces.
I'm sure it's extraordinarily powerful, and so is Trough, but it doesn't mean I'm excited to use it. And we brought some parts for them to show me how to program in new parts, because that's one of the things that's most challenging. And this one was actually took the longest, even though they had a pro service engineer. It's a little bit longer.
Yeah.
But its machine is really meant for high mix, quick turnaround, because you can load feeders while it's running. You can it's actually meant for very low downtime between runs.
Right, because if you're a contract manufacturer, you don't have control over the parts your customers are sending you. And
they could send you cut tape.
They could send you cut tape, and you might have to, if someone wants you to run, 50 boards, and then you have like 5 other jobs that day.
You can't have an hour.
Time is money. You can't spend an hour setting it up. So.
You can't spend an hour setting it up. So it has to be fast. One of the nice things is that you can take up the magazine, and a magazine holds like 16 feeders. You can load up. So
you can like preload a magazine for a job, and if the magazines are cheap enough, then you can.
They're not. I mean, they're not terribly expensive. They're like like.
But you could afford to have like a set that you have like so that while one job is running, a technician preps the other job.
You can load the magazine, although it's basically the same as just having multiple feeders. So it's just a little bit more elegant. Mm-hmm. It's not any cheaper because you still have to buy the magazine and these feeders to preload it, but you can load it live. I don't know. I mean, we went to a contract manufacturer afterwards actually and saw like a dozen of these MyDatas in action, and I completely understand why a contract manufacturer would want these. With the software that they use, you can manage it. It can handle like cut tapes. They're very fast to load. He says like he says between job time is like 5 minutes.
That's fantastic.
5 to 10 minutes. So like. But the question is like,
is that your work model? Is that the Adafruit model?
I don't know. That's why we have to check it out.
Yeah.
So we checked it out.
Next up. The other one in the running, Samsung.
Third up is the Samsung machine. The Samsung machine, for those who are very good at remembering stuff, these are the same machines we saw at the Arduino factory in Italy a year ago when we visited, and we came back and we had photos. I believe we had photos of the Samsung machines, right? We had a video even.
Yeah.
We had a video of the Samsung machines. They had a full Samsung line. And so we checked out Samsung, and they're extremely powerful machines. They make Samsung cell phones. So these machines are what is used to pick and place Samsung products. So they're no nonsense. This is the SM481 or 482. 482. One better than the 481. We hate the 481. We only like the 482.
This is a new Samsung Galaxy Tab.
Yeah, this is a Galaxy Tab. So I mean, look, whatever you may think about the Samsung products, they do make pretty serious equipment. This is a little bit Juki style, where it has the feeders on both sides. It's not long. It's very compact. You can see it's not a particularly large machine. Mm-hmm. It's meant to be in a conveyor. This machine is blisteringly fast.
Fastest one.
28,000 components per hour. That is the fast.
That is fast. Fast.
That is fast. It has, I also believe, 8 nozzles. I can never remember 6 or 8, 4, 8 or 6. There's like all these. You can also get multiple combinations.
And we brought this weirdo part to all 3, and this one, the Samsung was able to place it.
It is actually
learn the fastest.
And it's interesting actually. It's funny because we brought this odd part for them to it was non-rectangular like connector part, and I was like, can you do this? And it's funny because later on they gave us a brochure, and actually there's like half of the brochure is about how it's really good at handling odd-shaped parts. Like half of it is just
made,
that's one of its
these
features.
are made. They buy these from themselves. These are all made to make cell phones.
Yeah, so it's all just like weird custom parts, and so it actually uses like instead of using like an algorithmic like method, like many pick and places try to like count the number of pins and the squaring and the pitch,
and then determine what the package is.
This actually takes a photo, and then does an outline check. And another thing that's very interesting about the Samsung is compared to the Juki and the MyDay, and actually most pick and places, and also our pick and place. So our pick and place, when it picks up a component for fast placement, like a capacitor, resistor, not a chip. A chip you have to actually do like a slower registration check. But for a small component, you can do a quick check. The MyData does a laser. There's a laser centering. So what it does is it spins it while shooting a laser beam, and so it gets an outline of the part. And I think Juki also does laser. I can't remember. The MyData, I'm almost positive, does laser. And so that's very common for these parts, for small parts, for these pick and places. They do some sort of laser centering or mechanical centering or something. And what's interesting about the Samsung is they do have a bottom vision camera for very complex parts, but the flying camera actually is a camera. They actually don't use a laser. They actually take a photo of the bottom of the component, and they do that with a 45-degree angled mirror, so it looks at the bottom. So there's like a mirror, and it points up. So if the component's here and the camera's
so it's component
here,
upskirt.
So it's a component upskirt. Yes. Why did you say that? I have no idea. Where did that come from? Anyway, so yeah, it looks at the component, and so it's very fast. So you can actually do like small chips and transistors without like using camera vision.
So for the camera vision, normally it goes over to another camera, but for the flying camera, it's actually got a camera mounted on the head.
Yeah, so it's on the fly.
So it's got
a laser.
Right. So, but it's basically got a camera on the moving head with all the nozzles. So it basically just uses a mirror to check.
Yeah.
In
and
position.
Another thing that's nice about the Samsung, it's a ball screw drive. So it's a very.
Why is that an advantage?
I believe ball screws are a little bit slower, although like I think they can be engineered to be faster. But I believe they're more precise.
So as opposed to a belt drive?
Yeah.
Oh yeah, that makes sense.
Because the ball screw, it's like there's no backlash, and also you're less likely to get out of sync.
Yes.
Like ours is belt drive, and like the Y motors do get out of sync, and we have to synchronize them, and like you have to shut down the machine and do this like synchronization process.
Yes.
So like a ball screw is like a much it's heavier.
It's much more mechanically linked.
Yeah.
And so you can't really slip a ball
also
screw
like
in
the belt won't like stretch.
Yeah, like an.
I mean, there's pros and cons. Like I from what I can imagine, a belt drive is a little bit faster, but I think ball screw is a little bit more mechanically stable.
There's definitely a lot less backlash in a ball screw.
Yeah. Also, I think it has to be ball screw because it's to carry this camera head. Like
because it's load bearing, and if you like try to put something much more heavy on a belt, then like the belt sags, and then you can get a lot of rocking, and it's no good.
So those are the 3 machines that we looked at, and all of them actually do have smart feeder systems, although I'm probably not going to end up going for smart feeders because like they're 2 or 3 times more expensive. I'm probably going to go for dumb feeders and maybe have a barcode system that's separate, because like they have feeders that are actually like have like RFID tags in them, and I'm like, well, like we've never had a problem with a feeder mix-up.
Yeah.
Like I don't know.
Well, if you're careful with how you load the machine.
Yeah, I mean,
you don't have like a different operator coming in every day.
No, we also have a process, like actually one components stay in the same location. So like we don't change the first like 15 feeders on the machine. Like the first 15 feeders, like
they're all your standard parts.
I bought extra feeders so that the first like 10-15 feeders don't change. Like the first 10-15 are like pretty much stable, and also like when we go from design to design, I keep the feeders in the same location. So like if one project uses like an 8 megahertz crystal, every time we use an 8 megahertz crystal, it'll always be in that slot.
Yeah.
And if we have a 16 megahertz crystal that looks similar, it'll always be in a different slot.
That's great, because then like as you get more and more complicated projects, you can even just write an SOP being like this feeder goes in this slot, done.
But I do like the idea of having a barcode system. We have barcodes for inventory, and it works very well. And if as long as you barcode it when you first comes in, I mean, there'll always be like, did you send us the wrong reel? Like it will happen, but you can minimize a lot of these things. And I think all the reels do come pre-barcoded from Kemet or Yagyo or whatever, so we can use that.
And then just one last thing, some folks are asking the price range. Basically, it's a couple $100,000. So
yeah,
it's about $200,000.
The range is, I mean, it depends on like feeders and extras and whatever, but it ranges from approximately $120,000 to $250,000. So it's a lot.
It's a serious investment.
It's a serious investment. We take it seriously, which is why we went there and took photos with these machines. Yeah. You can tell.
One quick question: when will you getting the new machine? Probably within the next couple months.
They take 4 days. They take like 6, 8, 10 weeks.
And we will be keeping the other machine here just as a backup and for.
Don't try to dumpster dive the old machine. We're not going to be.
No, we're going to keep it. Also, we love that thing.
Yeah, it will probably still be doing stuff. It'll just be doing like
prototypes,
simple stuff, or probably do like maybe it'll like keep doing certain breakout boards or something, or if like the machine is loaded and we're like, oh shoot, we have to get another design in, but we'll probably still run it. But what we wanted to do is the current machine we have was about $30,000 investment, and I kind of didn't want to do it like I didn't want to like have a $30,000 machine and then get like a $70,000 machine and then get another $70,000 machine and then maybe upgrade. I kind of just wanted to skip ahead because I have a lot of confidence that we'll be doing a lot of pick and play stuff, that we will be using the machine. I want to get a machine that will last me for the next 5 years. I don't want to get something that in 2 years I'm like, oh man, like I didn't get something powerful enough, because you can get something like you can get a very powerful machine for a very good price, but like I'm saying if like for a 28,000 component per hour machine is only like a little bit more than a 10,000 component per hour machine. So like if you're going to dedicate money, I want to dedicate it to the point where I can like be done with it. I don't want to have like multiple pick and places. Like I don't want to have 3.
Well, no, and every time you have an additional machine to do effectively the same function, the opportunity cost is higher, both in maintenance and like well, how do you people develop preferences for machines? Well, I don't want to run it on that, I want to run this one, but also just there's a breakpoint for features that, when you want to make an investment for your business or for your lab, or you want to sort of project out, what am I going to need, not like next week, but what am I going to really be using in a year?
Yeah, this is like really long-term thinking. And you buy stuff for your lab.
Yes.
So it's a challenge because you're like, well, I don't want to spend too much. On the other hand, like, you don't want to have something that's just going to break in a year. You want,
if something breaks often enough and you find yourself constantly replacing it, then like after a certain amount of time, you're like, wow, I should have just bought the higher capacity, nicer, more robust thing, because then we'd still be using it.
And that's why we're getting a new machine, right?
Yeah.
Like, that's why we're not getting a used machine. And like, there's people get used machines. It's totally cool. I respect it. I understand it. But like, I just don't have time for that, and I need something that will last me. So that's why we're looking at a new machine. We're looking at these higher end machines.
They all look totally
they're all really sweet. We have a Google Plus post. So if you are a pick and place operator or you just like the LEDs on one of them more than the other, go and post up in the Google Plus thread.
Okay. Real quick, code is PMP, expires Sunday midnight, 10% off everything in stock. We're gonna do new products, very short new products.
I know.
Ladyada, new products to show them real fast, and then we'll have just time for just a few questions. We're all chatty.
Well, we had a lot to talk about. We were at Apex for 4 days.
Yeah.
We actually took a lot more photos. We'll put them up later.
What are the new products here?
Well, we have a nice little mini cable. So this is a dual cable. It has a mini and a micro end, because we have a lot of stuff with mini and we have a lot of stuff with micro, and I kind of felt bad that like we should have a cable that does both. So it's a little portable cable, and it's got a USB-A, so it plugs into your computer, Minty-Boost, or whatever. And then we have a micro connector on one end and a mini connector on the other end. And there's no hub in it, so you can only connect to one at a time, but whichever one you need, you can connect. So for example, if I have a Leonardo, I'd use the micro, and if I had a Flora, I'd use the mini, and so you can connect one. You can use them for data or charging. If you're using it for charging, you can connect both at the same time, but for data, you can only use one. Otherwise, they won't work.
Okay. And next
nice
up,
cable.
Kind of big announcement. This is a big new product for us.
Yeah, before I got on this plane, I rushed and put this product in the store. It's the ultimate GPS shield. So
Fully assembled.
Fully assembled. Really excited about this because we have the ultimate GPS module, and we also had the GPS shield. The problem with the GPS shield is it was using an older module, the EM406. It was expensive. It was big. It was not what I would consider a really great module. And people really like the ultimate GPS. And they kept asking us, how can I use the ultimate GPS module with the GPS shield? And like, oh, well, I can't really, and I guess we should make it so it does. So I redesigned the shield. It's like tons better. It's got a micro SD slot, reset button, tons of prototyping space. It's got a switch that will change it from direct to soft serial using pins 7 and 8. So it works on a Leonardo. I designed this after the Leonardo came out, which means that it'll work with the Leonardo out of the box. It doesn't quite work with the Mega because the Mega doesn't have soft serial, but I'll be posting up instructions on how to make it work with the Mega at some point. It's got the ultimate GPS module, a bunch of LEDs, coin cell for the real-time clock backup. So if you use that, you'll be able to have the real-time clock save time for like 7 years. And one of the nice things about the ultimate GPS is it can use an external antenna. So this is an antenna built in, and it works great. But let's say you're like, I want to have this in a box, and it's waterproof, or under a car or something. So there's a little UFL connector, and you can connect an antenna, and maybe we have a photo of it with the antenna connected. Thanks, Phil. So you can see, you can connect an antenna using a little UFL adapter we sell in the store, and then you can have this powerful antenna, and it's magnetic, you can stick it anywhere. And yeah, it's a great upgrade to the GPS data logger shield, but now surface mount, ready to go.
Is the RTC embedded in the GPS or a separate chip?
The RTC is in the GPS, but the battery is external. So it's why there's a coin cell. It comes with it.
All right. So that was new products. That was it.
Yay.
All right.
We'll have a lot more new products this week.
Yeah.
Because we're going to be...
Well, you have everything you didn't put out last week.
I really was going to put new products in the store while in the air, but it didn't really work out.
Okay, we're going to do 2 quick It's Not Out Yet, and then maybe a couple minutes of questions. We're just going to go a couple minutes overnight, because we always do when we have guests. Top secret, 2 things. Scratch badge, we got permission. They're on their way.
Scratch the cat.
Yeah, and I'm just going to put this out here. Coming soon.
Colin.
Awesome.
Looking hot.
So awesome. Sorry, ladies, he's taken.
Part of the wearable electronics projects that are coming out from Adafruit. This is Colin. That's all I'm going to say. All right. Speed round of questions, folks.
This is a good
Ask your engineering questions.
Ask was questions.
We're here to help you.
Okay, why is the triple axis gyro restricted from shipping to Canada?
You know what? I should have asked Obama about that, but I don't know. It is
The manufacturer said we can't.
it is restricted, and it's really annoying because I actually bought the gyros from Canada.
What? I had no idea.
Yeah, gyros are restricted. I'm going to try to figure out something around this because I had to sign paperwork that said I wouldn't export it when I bought these.
It's not a munition.
It is, actually.
Okay, next up. Any insights
Actually, it is.
on how the Maxbotics ultrasonic rangefinders stack up against the Divanitech?
I don't know about other ones, but I really like the Maxbotics. They're very good.
Those are the ones with the really nice big lenses, right?
What?
Or no, I'm thinking of the IR rangefinders, not the ultrasonic rangefinders.
No. The ultrasonic range of Maxbotics are quite good. I like them a lot. That's why we carry the full range. Very good.
All right.
Easy to use.
Any idea where one could buy supplies for winding their own transformers?
If there are lots of things you can use to wind your own transformer depending on your form factor. Things that I've seen work really well.
Just get a toroid, right?
Well, no, like
Wind on one side, wind on the other.
right, or like if you want to make, depending on the shape of the core, if you don't want a toroidal core, you actually like you can get cores that come together. But if you need to make a coil example, you can have just get any drive shaft for a drill, and you can do rotary winding. You can wind coils on bobbins, just any like rotary machine
like
you can use to
magnet
wind.
wire.
You get magnet wire.
I once bought toroids from some website. I mean, you can't get them like Juki or Mauser, but if you Google around, I actually got like
There are tons of people. Yeah.
Yeah. There's places that sell toroids, and toroids make a good transformer.
Yeah. You can anytime you just have sort of a continuous conductor, and then you wrap a coil around it, but. I don't know. People also, there are tons of businesses and small boutiques that will actually do custom transformer winding. It really depends on like the type of, because there's so many different types of transformers you can make. Some that require that you actually have like a full toroidal core. Some where you can put together, two halves of a core, and those are easier to wind, obviously, because you don't have to do it all by hand. But magnet wire
it's like modern,
is just really easy to get from any vendor, and
it's like modern crocheting.
Yeah. Just.
Right.
All
Next
right.
up.
Next up, what is RFID limited to? So what can it do and what can it do?
It's good for small range, slow data transfer. Very slow, very small range, like less than 6 inches.
Yep. It's not really good for any type of high bandwidth communication. I mean, if you've ever had 2 cards in your wallet and you go up to the subway, right, it gets really confused by having multiple things come in also, and we'll just like blank out one. It's not supposed to, but it does. So
They're supposed to handle multiple ones.
a lot of times it can't.
Is there long range RFID?
There are, but they're active. They're not. It's barely RFID at that point. It's actually 2 RF modules because
Talking, shouting over
yeah,
space.
because the RFID tag is powered.
Yeah, because so if you think of it, the energy for RFID falls off as what? R squared?
R cubed.
R cubed? So
Yeah, I think so.
As you get far away, if you want to activate an RFID tag that's really far away from you, you have to put a lot of power into it because you have to energize it enough not only to get the incoming signal to energize it, but then to be able to talk back over a long distance. It's very, very hard. So
I don't consider long range RFID. I think something else.
no, it's a different type of RF protocol. It's like an active RF protocol.
Yeah,
but it's not call and response.
That's like
RFID.
saying like a walkie-talkie RFID.
or the cell phone's RFID. Yeah. It's not. It has its own power source.
All right. I think we're going to do a trivia question.
Okay. What is the prize? Is the prize a GPS shield?
Yeah, let's do a GPS shield.
Okay. Your prize is an ultimate GPS shield. I think we still have some in stock.
We have one.
Yeah.
All right, what are the rules, Ladyada?
The rules are if you've won something, you can't win something again because we want everyone to have a chance of winning. So sit on your hands or go make a sandwich or make it a long-range RFID tag. The first person to answer correctly with spelling and all that good stuff in the chat is the winner. Don't argue with us. The winner will get GPS shield.
Yeah.
Not this one because it's assembled. We'll get you a brand new one.
All right, and the question is, what are the 3 brand names of the pick and places Ladyada is looking at? You can find this on the blog or on Google+.
Or if you can
3 brand names. You don't have to give us the model number, just the 3 brand names.
Although, that would be nice if they'd had the model number too.
No, they don't have to. Beer Cannon. Congratulations, Juki, Samsung, and My Data.
That's right.
Go Beer Cannon.
My Data is kind of a weird name. Like, what is My Data?
So Beer Cannon, email support@adafruit.com, and we will send you
A GPS shield.
GPS shield.
We should also probably say if you don't want a GPS shield, don't enter the contest, but whatever, I guess.
Everybody wants a GPS shield.
Everybody wants a GPS shield. So, so there's the 3 brands. I mean, and those are the 3 main brands I'm looking at.
Yeah. All right. With that, Waz, thank you for being on the show.
Thanks for having me. It's
Drop
always
us some
fun.
knowledge.
Cheers.
That's great.
Cheers. I learn new things every time I come here.
Yeah, we had like a record. You bring in a crowd. You always bring in the most people watching.
Yeah.
There's a Waz fan club out there.
Fan club.
All right, so we'll be putting new products in this week.
There will probably be new products. Well, I have to like reinsert myself into reality. So I got a lot of stuff going on, but we have some fun products coming in next week. Some brand new pick and place items. Hopefully, we'll make our decision. Maybe by next week we'll know what pick and place we're getting.
That'd be so exciting.
Yeah, and the other thing is, much like the first time we got a pick and place, we're going to let everybody know what we got, why, and hopefully we can have some when we get the machine installed. We'll film some of that.
Yeah.
This is all the stuff you never see.
No, you never. This is the inside scoop for.
Like big giant companies. We're now at the point where we're buying the same stuff they buy.
Yeah.
But they'll never tell you what they buy or who or why or where.
Yeah, it would be interesting to find out like what do like big manufacturers in Shenzhen use for pick and place.
I know what Samsung uses.
Yeah.
All right. So we know that for sure.
Like Foxconn, what do they use? Do they use Samsungs? I don't think they use My Data because they're not as fat. Maybe they use something else.
Maybe they do all hand placement.
They do not do hand placement.
Every iPhone is hand placed.
Hand sewn.
Yeah.
With
all right.
love.
Okay. MOSFET's not allowed in the factory. He's a cat.
So here's a photo.
Here's a picture of a cat.
Meow. Meow.
You barcoded MOSFET.
Yes.
Good job.
All cats are barcoded. All right.
In the future.
Well, we're doing cat inventory.
Yeah. And with that, here is your moment of Zener. Bye, everyone.
Bye.